Okay, students, last lesson of this topic. So obviously, test is coming up. Your Mathia should be finished after this lesson here. And then watching the practice test video and taking notes on that. You'll turn that in before the test. So I see that you've written down all the example problems that you'll see on the test and done review. Most of you should watch that video probably 3, maybe 4 times to make sure you have all the steps down for each of the types of problems you're going to come across. This, as I told you, is much harder than the last chapter by far. So I better be watching this 3 or 4 times. EL, at home, if you're playing a sport before the practice, etc. All right, page 599, if you're not already there. We're going over law of sines and law of cosines and finding another way of calculating the area of a triangle. So this is a review of what we have done. We have Pythagorean theorem there. When we have 2 sides given in a right triangle, missing the third side, we can use Pythagorean theorem. So I'd have x squared plus 10 squared equals 18 squared. You could pause the video and do all 3 of these, see that you know how to do these from the prior lessons, and then hit play and check if you got it right. It says solve for x, doesn't say round to nearest tenth. So we want an exact answer. That would be exact answer for x, and then of course we can reduce that down since we know 4 goes into 24, then 4 must go into this. 50, that's 24 left, 6 times. So that's 2 root 56. Okay, but then 4 goes into 56 14 times. So I always have to ask, can I reduce that radical more? And so that's 2 times root 14, which now equals 4 root 14. That's the exact answer. Hopefully you kept reducing the radical down. All right, here we have our hypotenuse and our adjacent sine, so that's cosine. So cosine of 36 equals x over 20. Cross multiply. 20 cosine 36 is the exact answer. We'll also practice rounding it to the nearest tenth. It could be tenth or hundredth in the decast. So 20 cosine 36. 20 cosine 36. 16.2. So approximately 16.2. Make sure you use the approximate symbol. And here we have opposite over hypotenuse, which is sine. The sine of x equals opposite over hypotenuse. In order to get rid of sine, I need to do inverse sine to both sides, and that cancels out the sine. And so now I do inverse sine of 7/12. That's the exact answer. Again, we're going to practice rounding. So inverse sine of 7/12. Second sine for inverse sine of 7 divided by 12, parentheses. 35.7 degrees. Okay, so there's a quick review of what you've already done in this chapter. Let's go on to the new material. Okay, so let's say we have a triangle like this. Is this a right triangle? No. Do we know what the height is? No, they haven't given me that. Remember, height or altitude would be that right there. I don't have that. Remember, the area of a triangle, as you should know, is 1/2 base times the height. We have the base, 22, but we don't have the height, so we can't use that to find that. So since can you use the area formula, 1/2 base times height, to find the area of this triangle? No, because we don't have the height. Can you use Pythagorean theorem to find the unknown length? No, because it's not a right triangle. We don't know if it's a right triangle, so we can't. Can you use the triangle sum theorem to determine the unknown angle measurements? No, you have to have 2 of those in order to get the third one. We only have 1. How could you calculate the area of triangle ABC? So there's a new way that you're going to learn, which is on the next page. So you could pause the video and see if you can think of how you could come up with this H and somehow plug it into that formula. That's what we're going to do. That's on the next page. Okay, so derive another version of the area formula. So we're going to go through these steps here. Write a formula for the area of a triangle in terms of B and H. We know it's 1/2 base times the height. Remember, base and height are always at the 90 degrees. So here's my B, that's the total base. So one side of it is x, the other would be b minus x. You learned that in our geometric means. Okay, and there's your height. It says write the ratio that represents the sine of angle C. So there's angle C as our reference angle. The sine would be the opposite over the hypotenuse, of course. So that is h over a. So sine C equals h over a. Now remember, we have h right there. So, and we didn't know what it was. So now we can solve this for h. Cross multiply, we get h equals a sine C. So what that means now is I can plug or substitute in, that's the word, substitute a sine C anytime I see h. Well, I have the h up there. And that's what it's asking you to do here, is rewrite the formula in part A right here with this new h. So I have the area equals 1/2 the base times the new h, which is a sine C. And they're just going to go ahead and put the A, B switching for alphabetical order. So 1/2 AB sine C. So that's another formula if you're in this situation that you can use. And so here it is right here, A equals 1/2 AB sine C. If you have, as it says here, two sides and the included angle. What's included mean again? Remember we talked about that with SAS, the angle is the included angle. That means in between. Remember? Included, and included is on the DCAS, in between. So notice this angle is in between the two sides. So if you have that set up, this is the formula that you would use to find the area of the triangle. Okay, so now we're going to apply that right here for number 2. So the area equals 1/2 now, so going back up here, where's A? You have to know where A is. A is that side. B is the other side. Okay, so A and B are the two sides. So A and B. Okay, again, you know, A is across, little a is across some big A, little b across some big B. So 1/2 A, which is 18, times B, 22, times sine of C, which is 32. So we have, I'm going to do half of 22 and get 11 times 18 times sine 32, because I can do that in my head. 18 times 11 is 180 plus 18 is 198 using the Schroeder property. You guys can just plug in a calculator. Now I have to plug that in my calculator. 190, I mean, you could have plugged all that right from the get-go into the calculator. I'm just trying to show you what you could do using your brain until you have to plug the sine 32 in the calculator. So 198 sine 32. 104.9. So it's approximately 104.9 centimeters. Let me make sure I read that right. 104.9, yes. Always double check. Okay, so there's the area. Area is squared, right? Because we got centimeters times centimeters is square centimeters. There you go. Go on to the next page now. Again, with this video, you can always rewind, go back, and listen to it again. Again, you need to get this stuff down. You can make flashcards to work on memorizing that formula, for example. Okay, next one we have the law of cosines. We're not going to derive like we just did in the last one. We're just going to look at what the law of cosines, law of sines is, and then which is now on page 604 that we're going to go to, which is 2 pages ahead, and just then apply it. So go 2 pages ahead, 604. And here's the law of sines. It says the sine of A over little a, which is the side length, equals the sine of B over little b and sine of C over little c. You'd pick any two of these situations. It could be the first two, it could be the B and C, or it could be A and C. You're only doing one of those proportions. Okay. So you're going to have, obviously, 3 of the 4 have to be given to you. Okay. So obviously, it's the angle and the side opposite. So here we have the angle and the side opposite. So that's one pair. Here we have a side, but we don't have the angle opposite. So we can just call it X. It doesn't matter which one you call it here. Okay, but that's the setup. If I have this situation, okay, an angle measure, one of the side lengths across from it, an angle measure, one of the side lengths across from it, only missing one of those pieces, I can go ahead and set this up. So this says the sine of 51 over its side length, 18, equals the sine of X, we don't know, over its side length, which is across from it, 22. And now we just cross multiply. So we got 22 sine 51 equals 18 sine X. Okay. Now we have to divide by 18 first. That cancels that out. Now we're down to sine X. Okay. Equals that. How do I get rid of sine? Inverse sine. So inverse sine of this whole thing, 22 sine 51. Okay, put this in parentheses, divided by 18. In parentheses like that. Okay. When you're doing the trig function, make sure you put parentheses around it. Okay, if you're trying to do it all in one problem, in one turn on the calculator. That's how, if you want to do it in one final answer on the calculator, you do this. Okay, if that's too difficult for you, you can go 22 sine 51 equals. Get that answer. I'll just put A and S for that because remember that's on your calculator. A and S down here is that negative, the second negative sign gives me, see if I hit second, that there's the answer. Okay, so that's how I bring that up on the calculator. I get that answer and then hit divided by 18 equals, get that answer, and then I do inverse sine of answer. Okay, so that's how I could do all that, because that way you're not doing any rounding, you're leaving all that in there. This is how you would do it in one step on the calculator. So inverse sine, what do I get? 22 times sine 51. 22, oops, I forgot to put the parentheses. Parentheses, sine 51, parentheses, divided by 18. Parentheses. 71.8. So it's approximately 71.8 degrees. Okay. So this is the law of sines. Okay. Now let's look at this called error analysis. Sometimes on the DCAS they have an error analysis where it's your job to find the student's error. Students made some common error. So side C is 35, side B is 28, and the measure of B is 40. So obviously we don't know what we don't know what C degrees is. The measure of C is be our X, or sine C as it says right there. So 40 is the degrees that goes along with B, which is 28. That's set up in sine C and 35. So this is all set up correctly. Set up the ratio, the proportion, correctly. They cross multiply correctly. 35 sine 40, yes. 28 sine C, that step is right. Okay. They went ahead and put this in the calculator. Now, the only problem with that is, again, that's a rounded answer. So they did change it to approximate. I would not do that till the end because it's going to put it off further, okay, than the actual answer. Now, they did, they skipped this step right here. They have sine C is equal to 0.8. So what they did is divide by 28 on both sides. And 22.5 divided by 28 is 0.8, and that's another rounded answer. But it is close to 0.8, so that's another rounded answer. It's going to put it further off. Now here's their problem, right? They did sine, so they'd have sine of C is approximately 0.8. How do I solve for C? I have to do inverse sine of 0.8. That's where they blew it. They did sine of 0.8. Okay, completely off right there. Okay, it should have been inverse sine of 0.8. In fact, sine of 0.8 would not even give you 53.1, so that could be an error even in the problem right there. Because sine of 0.8 probably is 53. So inverse sine of 0.8. Let's try it. Inverse sine of 0.8. 53, yes. Okay, so there's even an error. I found their error already. And as far as not writing that, they came up with that answer. Again, that's even further off because of another approximate answer. So that teacher here hadn't told the students that you don't round to the final answer. They've rounded all along the way, so they get further and further off. Okay. And so that would be what C is 53.1 degrees. They came up with both those answers. The other one could be is 180 minus the 53.1, which is 126.9. But both of these are off. They forgot the inverse sign there. They rounded up here, okay, which then puts your final answer off. So you would not see these answers of 53.1 or 126.9 on the DCAS because it's too far from rounding. Okay, so again, you don't round in math until the final answer. Okay, so notice ours is 71.8. That's not even close to the 53.1 that they got because of all their errors along the way there. Okay, and rounding there. Okay. Now, when I get 71.8, that could be 71.8. So 51 plus 71.8 plus measure of angle R equals 180. So then the measure of angle R would equal, that's 122.8. So 180 minus 122.8. So if I use 71.8 degrees, the measure of angle R is 57.2. Okay, or I could use 180 minus that 71.8 and get 108.2 for this angle here, angle Q. Right, is that Q up there? Dang it. That Q, yeah. Okay, or I could use this as the 108.2 and then add that to the 51. I get 159.2, and then the measure of angle R in that case, 180 minus 159.2 is 20.8. Okay, so those would be the two possible answers for the measure of angle R. But we're calculating the angle C. Oh, sorry, they didn't. They were using this A, B, and C there. Okay, so that's why ours wasn't close as far as that. But again, theirs is off because of rounding and then not putting the inverse sign, even though it came out to that. There's another error there. Okay. All right, let's go to the next page. The law of cosines. So we saw if our setup deals with two sides and an angle opposite one of those two sides and missing one of the angles, you can use law of sines. Well, what if it's not that kind of setup? There's another one called the law of cosines. We're going to go to the bottom. We're not going to derive it because, again, that's taking too much time. We're already at almost 20 minutes. We're just going to use it and look at an example or two. Go to the bottom of 606. So this is 605. So the next page, the bottom right here. Here is the law of cosines. We have three situations depending on which one's given to us, which two sides and the angle are given to us. So we look at which angle is given to us, and then the sides or which two sides are given to us to figure out which one of these three. You're only going to use one of those three. Okay. So let's go to applying this here. So notice here I have an angle measure here. I do not have its opposite side. We can call that X. But I also don't have this angle measure to go along with this side or this angle measure. So I can't be using the law of sines. I have too many unknowns. So this must be the law of cosines. Okay. So this would be little c. Remember, that's little a across from big A. And this is little b across from big B. So, and I have sine C. I have the angle of C. So when I come back here, I'm going to be using the, down here, sine, cosine of C. And then I have the little a and little b. So I can solve for side C there. Okay, so that's the one I'm going to be using since I have the cosine of C given to me. Okay. Now, what's a way that can help you memorize this? Notice they're all minus 2 times, and it's whatever these two letters are right here, BC. Those two are AC, AC. These two are AB, AB. And it's cosine of whichever these two letters aren't. Since those two are A and B, then it's cosine of C. Since that's A and C, it's got to be cosine of B. Since that's B and C, it must be cosine of A. And then whatever this letter is right here, that's what it is equal to with the little side of it squared on the other side. So you have to look for patterns on how to memorize because these really are almost all the same. They just switch the A's, B's, and C's around. That's it. Okay, so it's A squared plus B squared. The first two are just added and then subtraction of 2, whatever it is. Okay, so going, so you have to memorize that because again, that's not given to you on the DCAS. So we have cosine C, so we know that's at the end. So that's got to be A squared plus B squared, the other two sides minus 2, and it's those two, AB, cosine C equals little c squared. So that's now what we're going to solve for. C squared equals, what's A? 6,800 squared. What's B? 4,500 squared minus 2 times 6,800 times 4,500 times cosine of C, which is 122. Okay, and then to solve for C, of course, we got to take the square root of that. Square root of that whole thing. What we just have, all that right there goes underneath this radical. Okay, to solve for that C. So now it's, can you plug that in the calculator correctly? So I'm going to have to, obviously, there's a lot to plug in there, so I'm going to keep coming back and forth to this screen. You can pause the video and see if you can plug it in correctly, and then test what I have to see if you wrote down the right steps in the calculator right. So go ahead and pause that, and you try to plug that in the calculator. Okay, and after this, we're going to go to 610, which is 3 pages ahead, and do another thing here. So this is the one example, because again, length of time here. So square root. We have 6,800 plus 4,500. Oh, dang it. My error. I knew that didn't make sense because 3819 is too small for C. C's the largest angle in this triangle, so C's got to be the longest length. That's what I want to check. I typed in, see if you made the error, because again, I wasn't going back and checking. It is pen. Cosine. I typed in sine. That was my error. Everything else but that. Okay, so now here's a good example. See, that's a lot to type in, right? I don't want to have to retype all that in. So here's a good example of a positive thing that came out of this error. For those that don't know, I can hit second entry. It'll retype everything in that was above there and take you to the end, and I can back arrow to where my error was right there. Okay, hit delete, and I put in cosine. I gotta insert one letter, the number 122, go to the end, go out of it, and now hit enter. That's how you can, that'll save you a ton of time of having to retype everything in if you just made one simple error and a long thing that. So 9945.9, that makes sense. 9945.9 feet. Notice that's now the longest right there. 9945.9. Significantly longer than the 6800 and 4500, but that's also because it's the largest angle. Okay, that's why I knew I made an error somewhere. And I'm like, dang, I thought I typed all those numbers in right, but boom, I used sine instead of cosine. We just got done doing the law of sines. Now we're in the law of cosines. You got to use that. Okay, so you can go back and practice this. You could obviously pause the video, redraw this out redraw that triangle out on your own sheet of paper, and then see if you can do the law of cosines again, and then come back and hit play again, or watch or look over your work from here that you've already written down to see that you can plug it in right and do it right, calculate it right. All right, so now go to page 610, 3 pages ahead. Okay, of course, you're going to do all this for practice in the last lesson of Mathia. Obviously, this is the toughest lesson, the most work to type in, all that kind of stuff. So on this last one, this is the last one we're doing right here, is we're trying to figure out, is it law of sines or law of cosines that we would use? Okay, so notice I have an angle measure. I'm missing one opposite. I have an angle measure, and I have the opposite on both those. So that's going to be the law. Go ahead and hit pause, do it yourself, and then hit play to see if you got it right. Law of sines. Here, again, I have a missing there. I have this. Here I could use law of sines because I have 3 of the 4. But also, don't I have 3 of the 4 for law of cosines? I could also use technically law of cosines as well. Okay, but law of sines is the easiest by far. So whenever you can use law of sines, you want to use law of sines. That's just a side note right there. If you can use both, you want to use law of sines. It's much simpler to calculate. Here, okay, I don't have, I'd have 2 unknowns. Remember, and for law of sines, I need either 2 angles. I've only got 1 angle. So I'd have to have either the other angle, which I don't have, so that's 1 missing, and the sides opposite them. I have a side missing there. So I have 2 unknowns there. So that can't be law of sines, law of cosines. Okay, so remember, for law of cosines, I have the angle, the included angle. So then I have these 2 sides, and I have to deal with the side opposite. One of those can be missing only, and obviously the side opposite is the one missing. Okay, so here I have this angle. I don't have, I'd have to have those 2 and that right there for law of cosines. Well, here's a missing one and here's a missing one. So law of cosines would not work. I should put like that, different lengths. Okay, so I'd have to have 3 of those 4 given to me. I have 2 unknowns, can't use law of cosines. Again, I have this and this. Okay, those 2 I need. I'm only missing 1 right there. So law of sines. Okay, so that's the end of the lesson, 30 minutes almost. Again, this will be worth watching a couple of times. You will use this in Algebra 2 as well. So you'll be retaught this in Algebra 2.